I thought I'd try and show you this Proteus simulation of a proposed switched current hack for the Honda CRZ. This is a bit more sophisticated and subtle. Hopefully that should be a lot more reliable. Basically what we've got, this is for one of the phase sensors, and obviously we have 5 channels altogether. We have 3 phase sensors, and then we have the battery current sensor, which is a fine and coarse output. So what we have over here, we have the phase sensor input, and I've set this at 5 volts for now, just for the purpose of demonstrating this circuit. These first 2 components, resistor R1 and R2, they're actually inside the MCM. So I've included those here so that the impedance the sensor sees is the same as it would see if it was connected directly to the MCM. And then we have R2 and R3 here form a potential divider, which is operated by this switch S1, and that switch would be a multi-channel switch, which would switch all 5 current sensor channels simultaneously, be a digital switch basically. So that gives us a 2K and an 8K resistor there, gives us a 20% reduction in the voltage across the potential divider. So the voltage into this operational amplifier, which is just a non-inverting unity gain voltage buffer, and that basically just takes the voltage in and outputs exactly the same voltage but at a lower impedance and more current driving capability. And this is a voltmeter across here, just to show what the voltage is across the output, and then the output goes off into the MCM. So when in the MCM you would have the same 2 components as we have here. So basically I'm trying to keep the impedance the same across there as far as we can, and this is the simple voltage divider which drops us down our current sensed by 20%. So if I just click on run the simulation, so you'll see if I zoom in here, we've got 5 volts output, and the potential divider is not engaged. We've got 5 volts input and 5 volts output. So if I click the switch now, get my mouse, and we zoom over here, we'll see now that we've got 4 volts output. So that's a 20% reduction in the sensed current, and obviously that would then force the system to try and increase current, which it normally does with the IMA cars, and hopefully we would then see an increase in actual current from the system. And by using an op-amp and this sort of system here, the response should be very quick, and we shouldn't run into any problems with the frequency etc of the current sensors changing voltage outputs etc. So that's what I'm going to try next. So that's where we are at the moment.